We call it a binomial distribution, like the tossing of a coin, like when you play a game, you either win or lose. Or like a good example could also be couples who are trying to give birth, boy or girl. So all these fall under binomial distribution. And last time we said that for any random variable to be a binomial distribution, first we must have n fixed number of trials. And of the n, we can have x number of successes. And the successes do have what we call the probability of success associated with it. And then we have a probability of failure, which is called Q. So having identified all these parameters in a binomial context, you want to use this formula, and I think we couldn't use it last time. P to the power x times Q n to the power x. This is the PDF of the binomial distribution, and it's somewhere in your notes, somewhere there. And I think I remember asking you to change the R to X. You can keep it as R, it's the same thing, still the number of successes. Now, let me give you a typical example so that you know how to translate word problems into this type of what? Probability, before we even substitute that into the formula. Suppose I have a coin and I decide to toss it 10 times. So I toss it the first time, I get head, second head, third head, tail, 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 tail. 1, 2, 3, 4, 5, 6, 7, 8. Heads and tail. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I toss this 10 times. And this is a binomial because whenever you toss a coin, you either get heads or tail, right? So in this case, n will be equal to the number of 10. Excellent. And x will be the number of successes. So x, you will have to define your success. Suppose you and I, we kind of betting, and you go for heads and I go for tail. So if x represent heads, then we have it's 4. We have 4 successes. Does that make sense? So this is a failure because anytime it shows up heads, you win. If it's tail, you lose. So this is that. Now, what would be the probability of success for a coin?
6.
A coin, when you toss a coin, what is the probability of obtaining heads? 1/2. 0.5. And what's the probability of not getting a head? That's another 1/2, 0.5. That is the probability of failure, right? So if you want to compute the probability of obtaining 4 heads when a coin is tossed 10 times, you will use this formula to figure that out. How does that go? So it's going to be n, which is this, 10 factorial over, I'm just substituting the number, 10 minus 4 factorial times 4 factorial. P, which is the probability of success, 0.5 to the power x, and we know x to be 4. And then Q, 0.5 to the power 10 minus 4. And the rest will be...
Does P and Q always equal 0.5?
No, it depends on the contest. But P and Q must always sum up to 1.
Okay, and P is the probability that you're going to get what X is, what you're looking for.
Yes, that's your successes. Q is the opposite. You will not get what you're looking for.
The balance of what.
Excellent, yeah, if we're going to call it that. Yes.
So if we were plugging this
On your calculator, I've already taught you how to do that.
So it would be like 10 NCR 4, right?
That's right. This part is C10 4. This is the combination, the formula. So you know how to do that. Then the rest you just multiply by that.
How did you get the 0.5 again?
0.5 is because we're tossing the coin.
Oh, so there's only.
Probability of getting heads, yeah. So that's why it's 0.5.
So we don't really have to do that whole formula, right?
We have to. We need a calculator. So take out your calculators.
I know, but the calculator's freaking slow. I know how to do that, but do I don't need.
All right, so I'm waiting for you.
So the top part is premium again?
Come again?
The top part.
That's 210.
This 210, right?
Yeah.
210.
210 times 0.5 to the power 4. 0.0625. Right? Yes. And this 10 minus 4, I believe is 6. You know that, yeah? So it will be 0.5 to the power 6. What does that give us?
That's 0.01562.
0.01
0.015625.
625. Now, can we multiply all three and round to 3 decimal places? Calculators.
Error.
Oh no. Did you put them in parentheses? It's supposed to be 210 parentheses 0.0625 times 0.015625. What do you have? 3 decimal places. 0. Point 205, like that. Confirmation.
Yep.
Did you round up?
Yeah.
It's 0 after that. Awesome. So that's how we use this formula. We're going to look at 3 more examples as to how we use this formula, because it's very, very important. You need to know how to use it. Yep.
So and that answer, that final answer that you got, what is that? What does that mean?
This is about 21%, right? So you have 21% chance of getting 4 heads when you toss a coin
So of the event.
10
So
times.
you're looking for the probability of the event that you're figuring out.
You're looking for the probability of the number of things you are figuring out.
In this case, is where the event is we're looking for heads.
We're looking for heads.
If we did X is 6, we would be looking for tails.
Excellent.
Same, and things.
So you know that this is a game we're supposed to toss the coin 10 times.
And you'll
Okay.
always give us this information.
Oh, yes.
So, but do we know that by looking for heads, that the probability is 20%, then the probability for tails is 80%?
That's not what we're saying. We are saying that we're going to toss the coin 10 times.
Yeah.
When you toss the coin 10 times, what is your chance that you, out of the 10 tosses, you get 4 heads? These are your chances.
Only 20%.
20% chance that 4 of them
Only events.
will be the success. And if you turn it, then you're going to say that the other one will be for tails.
So
Yes.
basically, this is just finding out how many times you win, and then the original NCR was the combination of how many times you can get.
Basically, what you're looking for is the N, which is the total number of trials, X, which is the number of successes, which will also be provided, P, which is the probability of success. And if you have P, you can figure out the Q, because nobody will give you the Q. And everybody knows how to find the Q. It's just with the difference, yeah.
To get the 1.
Yeah. A good example. So assuming 8 students are going to take exams, so N is 8. The probability of passing the course or passing the exam, the test, is probability of success is 0.9. What is the probability that of the 8 students who are taking the test, 5 of them will pass? That would be 5 successes, right? So X will be equal to 5. So if you have these 3, what will be Q? Excellent. And so the question is, 8 students are about to take a test. The probability of success is 90%, which is 0.9. What is the probability that 5 of them will be successful at the test? So in your case, I can count around maybe 28, change it to 28, and we can figure it out, your chances of passing that particular test. So how do I find the percentages of passing this? So over here, we have 2 probabilities, and I don't want you to be confused. We have the probability of success, which talks about the event. But this time, we are not looking at a single event. We're looking at multiple, more of that. And that is when the probability formula comes in here. Great. Once again, we know it's n factorial, n minus x, x factorial, p to the power x, q to the power n minus x. We know what n is. 8 over 8 minus 5 factorial, 5 factorial. What is p? To the power 5. And the next one will be q to the power 8 minus 5, right? Which is 3. And then with your calculator, you can get the value.
The first is an 8 factorial as well, right? The top?
Thank you. So the first part is combination, NCR. So you can use your calculator. It's about 42, yeah? No, 56.
So then if you
This will be 56. Do you have the answer?
Yeah.
To 3 decimal places will be 0.033. Confirmation. Confirmation. Yes.
Okay, I'm sorry. So when you do the combination formula, what variables are you taking from that particular example?
NN. NNX.
So 8,
Yeah, 8C5.
8C5.
That's it. That should be 56. Confirmation. So it's going to be 56 times 0.9 to the power 5 times 0.1 to the power 3.
Is this on the formula sheet that we have or no?
Yeah, it's on the formula sheet.
Okay.
But pretty soon you realize it's not even relevant.
Oh yeah, it's the NCR. And you would give us it if we did ask, right?
Hey, I have about 1, 2, 3, 4, 5, more than 20 students here. I need the answer. 0.033?
Yeah.
Okay, we'll work with that. Great. My last example. What if this time n, we are told that n is say 15. And on the 15, we have 11 successes. The probability of success is 0.25. What will be Q? 0.75. So assuming that this even represent couples who are trying to have a baby girl. You are not there, I'm not there, so we're just giving the scenario. So we are told that they give birth to 15 children. No, I have to run away from that because in that case, P must be 50 because it's either boy or girl. So let's make it a multiple choice exams. Multiple choice exam. You know, you're usually given some possibilities to choose your answers from. So if you have 4 of them, A, B, C, D, of the 4, how many of these will be the right answer? 1. So the probability of success is 1 out of 4, right? Which is 0.25. Yeah, great. So you have a multiple choice exams, 15 questions, and you want to score of the 15, your goal is to get 11 correct. So you want to calculate your chances of passing that exam. Great. So in that case, n is 15. So it's 15 factorial over 15 minus 11, just substituting these numbers. And this is going to be 0.25 to the power 11. And Q, probability of failure, to the power what? 4. So take your calculators and help me out because I don't have one. 0.000. That is right. Are we okay? What is your problem? The no, where is it? Which one is the all of it? Which one? The last one? Is the same as the second one.
I don't like this number.
Yeah, it is. So we're only learning how to apply the formula. That's what I've done so far. I haven't added anything to it. And you can tell that these questions are even, the numbers are random. I just pick any arbitrary number and I throw it in there. Just so you get comfortable with the formulas. And once you are comfortable with the formulas, we can tackle binomial questions. All right? Any questions? Good. Now you have in your hand a binomial distribution table. That is our savior for now. Why? It's simply because if you have this table in hand, you don't have to do the computation because all the answers are on this. So I am going to show you how to use this table in place of the formula or the calculator.
Oh, you're funny, huh? We don't understand that, now you're going to show us.
No, you have to know both. It looks like a chemistry table. Which of the chemistry table is that? The periodic table? No. You don't see the chemistry and the body, the mass and the proton numbers over there. Come on. All right. Great. So let's learn how to use this table. Take your table, please. I'm not going to go through twice if you don't pay attention. All right. Now look at the table. It has 3 columns. The first column is N. Do you all see the N? The second is the R. You can change it to X since we decided to use X in this class. So you have NR and then you have P on the other side, right? P starts from 0.01 to 0.95. Do you see that? Make sure you're following because if you miss anything, it's going to mess you up. P is on top. P is the first row. The first row. Do you see that? It's in the same row with the R and the N. Is everybody okay? Now, under binomial distribution, as I mentioned, you need N, P, and then the X, right? So you notice on this table, Q is not even relevant. You don't need to know the Q to use this table. You remember this question here? What was N? 10. Therefore, on your table, look for 10. Have you found 10? Should be the next page. Turn to the second page. Is everybody set? Now look at the 10. Under the 10 on your table, you realize that the X's start from 0, 1 through 10, then 11, right? So these numbers represent the X. Is that okay? So if I were to solve this particular problem using the table, I know N is 10, excellent. So N is 10, X is 4, right? What was P? 0.5. So you check the answer. 0.5 and the 4. You should find this answer there. That is if we did the right thing. Are you looking at that 0.5? Don't look at 0.05. Look at 0.5 P. That's what we had here.
And then 0.05?
It's correct.
Yes, right.
So we did the right thing. Meaning you don't need the formula in your calculator to get the answers.
Oh, okay. So not 0.05.
Because you need to know both. You need to know both.
Yeah, right. I was just like, what?
So in this case, you're eliminating Q.
Yeah, on the table we don't need Q. In fact, you don't need Q to find the probability. Except when the P is not or the N is not on the table. Then you have to use the formula. And I'll make sure I give you something like that on the test so you can use the formula and the table. Is that okay? Let's check our answers. The second example, I think we had 8, right? Yeah, here. N is 8. So go to the table, look for N8. X is 5. P is 0.9. Check to see whether the answer is 0.033.
Yeah, 0.033.
This is just to prove to you that the table is good. Great.
Royalties on the test.
It will help you on the test.
So I can use this.
You can use it on the test.
Jesus, God is good.
How about this one? N is 15. This is 11. P is 0.25. You get 0.00000. That means if we see any binomial probability question, you can use this table to figure the answers out, right? So from here, let's look at some binomial problems from our textbook. So let's look at question number 37. From page 244. All right. Nielsen rating. Let's read it together. Don't stop solve anything because you don't even know it's a binomial. So I'm going to ask you so many questions. Because number one, you need to convince yourself that you have a binomial event before you even use the table. Nobody's going to tell you this is a binomial distribution. You've got to figure it out. So pay attention, try to understand how, and then once you are certain that you have a binomial distribution, then you can look for N, P, and the X. Awesome. CBS television televised a recent Super Bowl football game between New Orleans Saints and the Indianapolis Colts. That game received a rating of 45, indicating that among all U.S. households, 45% were tuned to the game based on wherever they got the information from. An advertiser wants to obtain a second opinion by conducting his own survey. And a pilot survey begins with 12 randomly selected households. Before we continue, is this a binomial situation? Or you were not. That's what makes it a binomial. Because the 45% represent those who were tuning to the game. It's either you were tuning to the game or you were watching something else. Who cares about Super Bowl? Or probably you were a lover of football, so hey, there's nothing you do on that day. You want to watch it. Does that make sense? That makes it a binomial distribution. Great. If it's a binomial distribution, what is N? N is 12. So N is given. So unlike my examples where I give you the N, over here you got to figure it out. So N is 12 because you were given. These are the number of randomly selected. What is P? 0.45. That is also given to you. The only thing left in order to find the probability is the X. And the X is usually in these questions. X will never be given up here, so we associate it with the actual question. So let's see if we can find X. Find the probability that none of the household is tuned into this game. So what will be X? 0. So what is the probability? You take your table. and you go to 12. N. X is 0. Probability is 0.5. And the answer is 0.001. And that is the answer.
That's
So N12.
And that is the answer. But if you do not have the table, then you have to use 12 factorial over 12 minus 0 factorial, 0 factorial, 0.45 to the power 12, and 0.55 to the power 12 minus 12, which will also give you the same answer. So why waste your time?
Shouldn't even showed us that.
In that case, you'll be a deficient statistician. You will lack so many things. You go ahead. Who taught you, Francis? And he never taught you that? It's a bad professor. All right. Great. Are we okay with that? Can we go to the second one? Let's look at that. Find the probability that at least one household is tuned to the game. What is the meaning of that?
Between 0 and 1.
At least one. One or more. So what's the meaning of one or more?
So 11.
What are the 11?
2, 3, 4, 5, 6, 7.
Excellent. So we're looking at 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10, 11, 12. That's the meaning of at least. Yeah? Good. Good news is you have everything listed on your table.
So what's X in that case?
X. X is 1. X is 2. X is 3. X is 4. X is 5. X is 6. Excellent. We have to do it for each one. So if you do not have the table, you can imagine how long that would take you to do the you just add up everything there.
I was freaking out. I was like, oh my god, that's
We don't, this is going to take us forever. We don't even have time for that.
So you find it for all X and add them up?
Yes, and everything is on the table, so you just add them up.
So from 1 and down, we add
One and down, you add them up, and then you get the answer.
P is the same P, right?
Yes, it's the same P. It's a continuation of that.
so from 0.8 to 0.
Is anybody here who still doesn't get it?
I'm laughing.
On which one?
Like, at the whole thing, diagonal thing. I don't know.
Then I think the next example may be helpful.
So, question.
Because it cannot be the whole thing.
I mean,
Uh-huh.
do you just add 1 to 2 to 3, 3 to
No, we are not adding 1, 2, 3, 4. We are adding the probabilities of 1, of 2. So this is it. This is your table. You have 0, 1, 2, 3, 4, 5, 6, 7, up to 12, right? And then you have P's here. The P here is 0.45. So you're going to take the probability of 1, probability of 2, probability of 3, probability of 4, up to 12, and you add them up. You're adding up the probabilities. Is that okay? Now let's go to the next one. Find the probability that at most one household is watching or is tuning to the game. 1 and 0. That's the meaning of at most, 1 or less. So you look on the table, 1 and 0. Add them up. And then you get your answer. It's not really difficult.
So I have a question.
Yes,
What's
sir.
the point of adding it up? It's like to make it less answer or?
No, it's because we were asked at least 1. It's not
After you find it, you have to add them?
after you find what?
Uh,
The probabilities?
For all 12. So you have to add all of them?
Yeah, because here at least means 1 or 2 or 3 or 4 up to 12. And I taught you earlier on that when you see the word or, what is the meaning of that? Now you know why we added. If at most one household is tuning to the game, does it appear that 45 household value is wrong? That's interesting, right? What is the answer to C? Because C talks about at most. Don't forget that. 009. 009 is the answer for C. And question D is a continuation of C. If at most, this is tuning, does it appear that the 45 share value is wrong? Why? And why not?
Because it was saying the problem was saying that it seemed among all U.S. households, 45% were tuned into the game.
45% were tuned into the game. And down here, if at most,
If at most one household is 0.9%.
No, it's less than one.
I would say that the value is right.
why?
Because again, in the original questions, it's not giving a specific number, it's saying that a certain percentage was tuned in and that was 45%.
And then we computed this
If
percentage.
you have at least one household that's tuned in, that's part of that 45%. So, I guess I'm not making sense. I need to see the question.
Oh,
Wouldn't it be false because it's not closest to one, it's further away from one, technically?
why are we using 1 but not 2 or 3?
Is that what we're supposed to do?
Yeah, because probability always go up to 1. That's good, but it's not a 1 though. Yeah.
So they're saying that their rating of 45 indicates that 45% of households were tuned in.
45% of household were tuned in, meaning that for every 100 people you select, 45 of them will be watching the game.
Right.
That was your chance that a household will be watching that.
So multiply 12 times.
Can you compare the two? Because the .009 is based on 12 randomly selected households, not 45 out of every 100.
It's not really hard.
What's the logic?
What's the
Because the logic here is over there, they are not looking at the big number, they are looking at the 12 people.
So what if we find like the percentage of
What we just found, right,
Was that nobody was watching?
is that it's related to the 12, not that big thing they did.
Exactly, okay. I follow you.
Does that make sense a little bit?
Yeah.
Because this 45% was done by CBS. Now there's this advertiser who is a little bit skeptical about this information. So it's like, okay, let me find out whether this value they give to us is really true. Or probably as a statistician, you want to find out whether they're giving the right information. So you're like, okay, why don't I just sample 12 household to make things easy for yourself? And of the household, how many of them will be watching the game? So over here you're talking about, well, what's the probability of just 1 out of the 12 is watching it?
Out of just one?
Yeah, that's it. Because that's what he's saying here. Do you understand that? At most 1. It's either one person, one household is watching, or no household is watching.
So it's
wouldn't it
the
be
number
false
so
then?
low, but it doesn't even add up to that person being watching, so there was nobody watching the game.
How would you know? This number is not a numerical value. This is a fraction.
That's one household there, right?
This one?
That percentage there is one household?
No,
12
it's
households.
Oh.
1 or no household. Because it's at most 1. It's 1 or 0. You see, the problem here is before you do any of this critical thinking, now I'm beginning to think to put 1 on the test because some of you are not even paying attention. What you want to do is try to understand what the question is talking about. And that's why all these pieces are coming up. What is that? What is that? What is that? So we try to
So wouldn't it be wrong? though?
explain. Why do we
He's trying to prove that 45% and he's taking a fraction of that, and then within that fraction, it doesn't even hit 45%. So wouldn't it be, it's not, right? Wouldn't that be the answer?
No, you are interpreting it from a different angle altogether. If we want the 45% of 12, you can multiply 12 by 45%. And then you get to know the number of people that will be watching out of the 12. That will be the 45. But that's not what we're trying to do. What we're trying to do is to find out that of the 12, how many of them are watching. Because you know that if you pick one household, it's either they are watching or they are not. But then if you multiply the 12 by the 45, you can be certain that this is the number of people who are watching. That number, the number of households do not have option. They are watching. Whereas, if we were to think about the question from the way it was given, you pick the first household. Are they watching? Are they not watching? Put it aside. Second household. Are they watching? Are they not watching? So you don't know. You want to find out what is the percentage that they will be watching that. I think it's a good critical thinking question for homework. Yes?
Do you need the first part of the question to solve the second part of the question?
Yes, you do.
It seems like they're not, I want to say, mutually exclusive as on the homework.
Maybe you want to say they are mutually exclusive.
Because if the one happens, the other one cannot.
'Cause mutually exclusive
I'm
means
sorry,
they have nothing.
They are not mutually exclusive because they're dependent upon each other here, right?
In that case, you don't use mutually exclusive. Mutually exclusive is when they have nothing in common.
Correct. So they're not mutually exclusive.
I'm getting so confused. Can we just find out the answer for good?
It's very difficult for one to say they are not mutually exclusive because in that case, you introduce the element of dependence.
But do you need the game rating?
No, it's good. This is good critical thinking question. Yes,
You
sir.
need the 45% in order to figure out, if you're looking at the last part of the question, if you sample 12 households to figure out, like you said, either it's 0 or 1, how many households were watching. Do you need that first part of the information, or is that?
Yes, because that is what we excel. That's the probability of success. We need that to figure out the probability we are after. Yeah, sorry, don't hurt your head.
Change your x value from 0 or 1
Ye-
there to figure that out in the second part.
So 0 or 1.
Right.
And that is this level of percentage.
Is that just with x as 0
And 1.
and 1? Oh, added together.
It added together. Aha.
So that is the percentage.
That is the percentage.
9%? Is that 9%?
It's not even up to 9. It's not even up to 1%.
0.9%.
So you know what I want you to do?
This is why we can't have a test on Thursday. Something like this. I'm serious. I still don't understand. So you're saying
Is this on the test?
No, I hope not.
Let's think. Let's think.
If you multiply that percentage by the 12 households,
What would that be?
it's like 10%.
Oh no, it doesn't give you 10%.
It gives you 0.10.
It gives you 0.1.
108.
And that is not a percent.
It's not a percent.
I think the problem here is
So would it be 1.08?
we should be able, right, to differentiate between the discrete numbers and then the percentages. That's what's going on here. And that's why, because if I say the whatever this is supposed to be, oh, yeah. No. It's not going to be yeah. This guy here is a decimal. It can never be more than 1. It is the probability.
I mean, that doesn't really help.
It doesn't, yeah. It's a probability. This 12 here is the discrete, because you cannot say, oh, I interview 11 and a half families. It doesn't make sense that way. When I multiply 12 by that, it should give me a discrete number. See, that's the problem again. Let's talk about money, because everybody likes money. Suppose I have $100, right? And I want 30% of the $100. How much would that be? You see how you convert the percent and this to $30 all of a sudden? You do it just like that. I need the same reasoning transported from there. It's the same thing. So you notice, that's the problem there. So I need to bridge that gap. Because some of you feel there is a gap between the two, but they are the same. Yes.
So, because you gave 100, so what we'd have to do to get, like, let's say that very direct number, we would multiply 12 times 0.009 and then take out 45% of that. Is that what you're trying to say?
Now it's becoming complicated.
That's exactly.
Now, when you multiply the 12 by the 0.09,
You said you'd get a discrete
it gives you a discrete number.
and then we would get the
Do we know that discrete number? So why don't we figure it out first before we start reading the other stuff? What did you get?
For what? I was thinking like it's 45 out of like 100 households at first, 45% out of.
Yes.
So that's 45 households, and then 12, is it 12 out of 45?
No, 12 becomes 100%.
12 becomes 100%.
My answer is no,
0.108. So it's closer to what number? No.
one. No, not one, sorry.
When you just multiply the two, the 0.9 out of 45 and then that times the.
No, you have already used the 0.05 for that. So already the 0.05 is an integral part of that.
So that's 0.9. So would the number be a decimal point then?
No. Whatever you get, you must run it to the nearest whole number. So if you get 0.1 something, what is the nearest whole number?
0.108.
Yeah, 0.108 to the nearest whole number will be zero. So I think that is where the problem is. The problem is with the numbers. It's not the interpretation. And this is not 093. I would have broken it down for you. You were expected to know. Like you're supposed to know.
Okay, so for this answer, because this is saying it's close to 0,
This is saying it's close to 0 out of 12.
so then it would be no, because it's not accurate, right?
How would you know it's not accurate?
So the answer would be we just wouldn't know then, since we're not taking the full data.
You have the reasoning, but you just can't prove your point. Let me do you a favor, and probably you also do me a favor. When you get a chance before Thursday, I think. Why are you so scared of Thursday? Some of you pray Thursday never comes. Okay, in that case, we can postpone the test.
Monday. So this is that.
Next Thursday.
I'm giving you a homework at the moment.
Yeah.
Homework is already open.
Yeah, the homework.
After I read your email, it's open.
Cool.
After.
So our answer would be that
I love this question. And I would like you to go and dig. Because on Thursday, let me point out some few pages to you. No.
You just said that, yes.
Let me point this out to you. I want you to go home and read. When we come back and you don't read, I'll put it on the test.
okay, what page is it?
Right, tell me, what are we reading?
Yeah, I'm looking for something for you, which is kind of related to this.
Blood pressure just dropped a bit.
Oh, how. I didn't mean to give you. I didn't mean to. raise your blood pressure by telling you have a test on Thursday. Oh.
I have the pages. Do you want to look at the pages? Is that easier?
No, I'm interested in some specific wordings here.
Look up search for a word.
No.
What is it called?
I think the book, even if the book doesn't, then I may have to talk about it next time. But
What are we looking for?
I'm looking for some of these. All right, great. Do this. Page 237. Page 237. There is a question there called example 3. Exalt method for gender selection. Right? When you get a chance, since it's an example, they've already solved the work. But I want you to understand the interpretation of that information. And that goes to 238. So read everything. Then you stop just before example 4.
So the question we were on originally that we're trying to answer.
No, we will discuss that.
We will discuss.
Yeah, we'll talk about that in class. That is when I realized that you have read.
Oh, okay.
Because once you read,
We will.
it makes it easy for me to explain it to you. Otherwise, I'll be saying that you just be taking it, you go home and you forget again. Yes.
Electronically or manually?
Electronically.
Electronic.
Because manually the pages differ.
Yeah, that's why I asked.
Yeah, the pages differ. I don't have my time, but I like it. I'll do another example. Let's do another example and skip these. Oh, this one doesn't even have anything, so. Yeah, let's look at that. I'm going to blow it out a little bit. Question 29. And that also has a critical thinking question at the end. That's why I'm choosing. Oh, really? It doesn't? Oh, yeah. Oh, no. I don't like the unusually high. I don't teach the unusually high and the low here. It doesn't matter. 29. See you later. Based on the on the Harris Interactive Poll, 20% of adults believe in reincarnation. Assume that 6 adults are randomly selected. Find the indicated probability. Is this a binomial distribution?
No, because there is
No,
one.
because there's multiple.
How would you know there's multiple? So, is it a binomial? Why would it be a binomial? You say that you believe in reincarnation or you don't.
2 outcomes, right?
2 outcomes. So when you read the question, you should be able to convince yourself. You see, that's where we can't even interpret the logical reasoning because we don't even understand the question. Sometimes I ask some of these quote unquote silly questions just so you get to understand the question. So sometimes you're like, why is he asking this? Why does he think we're dumb? No. That's how we learn statistics. So I'll ask you, I see the number, I'm asking you, what are we looking for? So the moment you begin to think, that's when you're able to interpret results. Nobody has said it's easy. Did I say that? No. But we try. All right, so let's go. Now that we know it's a binomial distribution, we need to know n. What is n? Boom. What else do we need to know? P. So what is P? 0.2. Let's go to number 1. What is the probability that exactly 5 of the selected believe in reincarnation? So X will be 5. So how do we find the answer? Go to the table. .0002, right? Yes. You agree? Now, what is the meaning of the .0002? Oh, no. What is the meaning of the .000?
Probability that of the 5 adults that they
Does that make sense?
Yeah.
That means when you select 5 people out of 6, the probability that they will believe in reincarnation is 0.0002, which is almost 0. Does that make sense? So don't just do the numbers. Who cares about the numbers? You should be able to interpret that. Number 2, what is the probability that all of the selected believe in reincarnation? So what will be N? N will be 6 because all of them. So back to the table. Is 0? 0, 0? Okay. Now let's go to C. What is the probability that at least 5 will believe in that? What's the meaning of at least 5? 5 or more. So according to our question, that would be 5 and 6. Excellent. So go to your table. What would be the probability of 5 and 6?
0, 0, 0.
0 is added to.
0, 0, 0.
You have 2 0 0 0.
For 6? Oh, hold on. Sorry.
So if you combine the 2, what does that give us? 0 0 0 2. Yeah. So what is the meaning of the 0 0 0 2 now?
5 or more out of the 6 believe in reincarnation.
Excellent. So don't just compute the numbers. Try to understand the numbers. So the last 0.0002 represent your chances of selecting 5 out of 6 or 6 out of 6 who believe in reincarnation.
So like 6 of the randomly selected 5 is an unusually high number based on the questions we just answered.
Unusually high is a formula. I haven't taught you anything like that in this class, and it's not really, but it's given by this. You remember this?
Yeah.
The mu, sigma. Then you can use that. Yeah. So this is unusually high and this is unusually low if your values are below that.
So we're not
So
doing
mu is the total population.
Come again?
Mu is the total population.
Mu is the mean.
Oh, the mean of the population.
I haven't taught you the mean and the standard deviation for binomial yet. I'll be teaching you that on on Thursday. Great. So please start with your homework, okay? So since I've postponed the homework to next Thursday. Did I say homework?
Yeah.
No. How can I postpone homework? I mean the test to next Thursday. I'm going to advise you to find time to go through the chapter 5 homework questions, right?
Yeah.
If you don't understand anything, bring it to class for us to discuss together, okay? Good. Help yourself, otherwise we can't help you. Thank you for coming.
Thank you for doing postponing the exam.
You're welcome.